In this video, we're going to have a look at how to use Google Sheets to create a scatter plot, as well as how to calculate Pearson's correlation coefficient. This video is part 2 in a series on how to analyze data. So on the left over here, I have some sample data where we're trying to have a look at whether height has any effect on arm span. So height being the independent variable, because it is a continuous variable, we're not going to make a bar graph from this data, but instead we're going to make a scatter plot. Now, for starters, you'd think that just highlighting all the cells and creating a chart will do the trick, but Google Sheets, the current build of Google Sheets, is a little bit funny. If you do that and select scatter, it looks all well and good, but if you look closely, something weird's going on down here. It sort of treats the numbers as if they were like categorical values, and the way you actually, I'm just gonna get rid of that. The way you actually get it to present it correctly is to actually select the two columns at the top. So I'm going to drag across A and B, and by doing that and clicking Insert, Chart, and then changing the chart type to, it actually will suggest the correct one for you, scatter plot. There it is. This is the correct way that it should be presented, as you can see, looking across the x-axis scale. So let's just go ahead and fix up some of the formatting. First thing I'm going to do is remove the chart title. And then I'm interested in seeing whether I can add a trend line. This can be found under Series and Trend Line. By default, it chooses a linear line to put in, which in this case seems to be an accurate representation of where the dots, the points seem to be going. But I do have the option of choosing different types of trend lines. Note that you can actually tick a box that says show R squared. This, however, is not Pearson's correlation coefficient, but the coefficient of determination, which, while also being very useful in science, is not what we're interested in today. And finally, I'm going to go ahead and get rid of the legend, because I only have one set of data here, and that doesn't actually give me very much information. So what can we conclude from the data here? Well, it's pretty clear that there's it seems to be a pretty strong relationship between height and arm span. It seems that as height goes up, so does arm span. But of course, as you may know, this isn't enough to just visually estimate that there is a relationship. We want to perform some sort of test that gives us more confidence that there is. And of course, the one that we're going to use today is by calculating Pearson's correlation coefficient. There are two ways of doing this, very similar to the t-test, as I showed in the previous video, and I'm going to demonstrate each one. So the first way of doing this is by using Google Sheets inbuilt formulas, and the way you do this is by selecting any empty cell and typing in equals, and then Pearson. Once you start doing that, it'll suggest that for you, and then you just need to input the two data sets. So let's start with this column here, comma, and then let's highlight these numbers here and enter. And there you go. The second way of doing it is by using Excel Miner. So I explained in a previous video that if you don't have it, you just go to Get Add-ons and you can add it there. But once you've installed it, select Start, go to Correlation, select all of the values from both groups in input range, and then once again select any empty cell for the output range and hit OK. Just going to get rid of this so we can see the data a little bit more clearly. And as you can see, it outputs the exact same two numbers. So a couple of comments here. One, what conclusion can we make? Well, as you may know, if it spits out this number, 0.89, we would say that there's a pretty strong correlation between the two variables. Any number that's higher than 0.7, in some cases higher than 0.9, we say it's a strong relationship. And so that's heaps better than just looking at the graph and saying, oh, you know, it looks like the line's pretty steep or something. Now that we've got this value, Pearson's correlation coefficient, we can say so much more. Secondly, why use Excel Miner if it's so simple and straightforward to just use Google Sheets inbuilt formula? Well, yes, I mean, you're right. You could just do it that way. What Excel Miner provides, however, is a bit more flexibility if you actually had multiple variables that you were looking at. I'll give you an example. So I've just entered a third variable into this data. Say I also collected the person's foot length in addition to their height and arm span. Look what happens when I repeat the process with XL minor. So choose correlation again, highlight all of the numbers, input range, select an empty cell for output range, and hit OK. This time, as you can see, it's done the work of calculating the coefficient for all possible combinations. So it compared column 1 to column 2, height to arm span. It compared column 1 to column 3, and then column 2 to column 3. You can do this, of course, just typing in the formulas using Google Sheets, but this just does it a lot more quickly. So I've just replaced those column labels with what the variables actually are, and just at a glance, you can see now really quickly how closely related those variables are. It looks like foot length and height have a sort of moderate correlation, but foot length and arm span does not have as strong a correlation. And there you have it. Some little tricks to keep in mind, like remembering to select the columns when you're creating the scatter plot, and using formulas or XL minor to calculate Pearson's correlation coefficient. But I hope that was helpful.